But I would say the last few years have been a real eye opener for me, which obviously speaks to the amount of privilege I've had that it's taken the last few years to realize kind of what's happening in the world. It's something that I do say about myself, although I think there are many folks who do this work much more actively than I.
Yeah, but I think the humility says a lot about you, and also, like you said, the last few years have kind of been a push to be an eye opener and see what's going on, but then also how each one has their own part to play, their own role, and how they can do that. And anyway, so just getting these things out in the open, I think, is healthy. But anyway, apart from that, can you tell us a little bit about your background, about how you got into tech, and then more specifically how you started working with Kubernetes?
Yeah, absolutely. So I'll kind of take you through my own introduction. So I'm currently an SRE at Google, a site reliability engineer. I'm part of the customer reliability engineering team. So unlike other Google SREs who work on Google systems, whether those are internal systems or like cloud services that people may be using, my team works with cloud customers to help them adopt and implement SRE practices and principles and to really kind of achieve the appropriate level of reliability for their services running in Google Cloud. I've been in various customer-facing technical roles in over kind of many companies over the last, well, God, it's close to 20 years at this point. And I've gotten, I went into SRE within the last few years because of my interest in reliability, because I believed, like I will be talking about today, that reliability is a key feature, that it's like the one thing you need to keep your users actually happy with your system. And it's also something that honestly we don't pay attention enough to. I kind of draw a parallel with the folks that work in security, who I think have done a very good job of convincing everyone that security is basically table stakes for any internet-facing service, and obviously lots of internal services as well. And those of us who work in reliability, I think, still have a ways to go to get to that point. Specifically to answer as to how my experience or kind of how I work with Kubernetes, and now obviously, we here at Google Cloud, we offer the first fully managed Kubernetes service in GKE. And then when I'm working with customers, or I have worked with customers, obviously we have lots of customers that run lots of services in GKE on Kubernetes, and so I've somewhat by necessity, but also by dint of interest, have had to learn quite about it. With that said, I also want to manage everyone's expectations. My talk today actually is not it's not about Kubernetes, and it's not really about data on Kubernetes. So I hope folks will still be patient with me.
No, I'm sure we will. But also, can you just unpack that a little bit more about the customer liability and how that differentiates from the other team in Google? Because we, just on LinkedIn, on Twitter, we see a fair amount of activity coming out. Obviously, the books, they've been written. Customer reliability, what exactly does that involve?
Yeah, that's a great question. So my team, CRE, Customer Reliability Engineering, work with Google Cloud customers to make sure that they have a sort of good experience where reliability is concerned on Google Cloud Platform. We also do a lot of coaching and guidance for customers who are interested in adopting, SRE practices and principles, some of the fundamental ones I'll be talking about today, into their own environments. So if you have customers that may be coming from a more traditional development and operations split, or maybe they've moved into DevOps, but they're still having challenges either around making their services appropriately reliable, or continuing to maintain reliability and scale and managing the operational toil and the load that takes on their teams. This is something that my team helps with. So we can sort of basically take some of the lessons that we've learned at Google, operating these enormous systems without having enormous operational staff via things like automation, and help our customers adopt some of those principles and practices as well. So we work, like I said, with cloud customers rather than owning the reliability of specific Google services or Google Cloud services.
Very, very good. I'm sure you'll be talking about this later, but from previous conversations with SREs, we're talking about the subject of SRE. One of the major things is, I know it's in your title, is talking about SLOs, but then also SLA and SLI, and how ownership role for SRE is not purely a technical one. Rather, there's a business relationship, related to expectations of a service as the SLO, SLI, and SLA very well indicate, service level. And so I think that's maybe somewhat of a shift for some folks that come purely from a technical background and perhaps haven't had so much contact with customers. Would you agree? What do you think about that?
Yeah, absolutely. So I view SRE as sort of the primary owner of ensuring that the customer, whoever and however you define customer, right? It could be external users, internal users, it could be other services, whatever the case may be. We're the ones who are really on the hook to make sure that the customers are actually happy, that the customers continue to use our service, that the service grows, and that we don't shed customers because we're unable to meet their expectations. So it really falls to us to kind of work across organizational silos to identify, who are our customers, what do they care about, why are they using our service, what is it that they're trying to do, and how do we make sure that we actually enable them to do that without the reliability of our service getting in the way. How do we make our service reliable enough to keep our users happy, while at the same time avoiding, provisioning excess capacity or over engineering or overspending on infrastructure. And so sort of balancing efficiency against user happiness and reliability.
And I imagine as well too, that's not something that's necessarily set in stone, that there's probably somewhat of an element of give and take, like you said, that balancing act. So that's, I think, another thing that has to be built in as a component of knowing that your first attempt may not be right on the money. Is that correct?
Absolutely. We always tell folks that you got, start with a target, whatever that may be. It doesn't have to be perfect, because you will iterate on it over time. You'll learn more about your service. You'll learn more about your users. And yeah, it's never going to be perfect. It's always something that should be reviewed on a very regular basis.
Yeah, but I think it's healthy to have that built in, so you don't, you're not killing yourself that you didn't get it exactly. But also, once again, educating the customers that, once again, questions of expectations. Like, we would love it to be 100%, but 99 point whatever is still quite good. Anyway, good. So that being said, crack on.
Awesome. Well, thank you so much. So I've used the word, and we've used the word reliability quite a few times at this point, but before I dive in, I want to make sure that we do get on the same page as to what we mean when we say reliability. And it certainly means preventing outages and crashes like these that make their way into the papers and the technical articles that can have like an immediate top line impact on the business. But the costs of unreliable systems extend far beyond just a big outage. There's a study that I saw a couple of years ago that showed that a team of 10 engineers will spend about $300,000 worth of their time every year on troubleshooting and incident management. And there's another study from IDC that said that investing in reliability can improve or protect up to $1.2 million of revenue a year. So the point here is that the reliability of your service is a feature of the service, just like anything else, which means that you need to prioritize it, you need to work on it, you can't just take it for granted. But if it's a feature, then the obvious question is, well, like, how should we measure it? We measure the adoption and success rate of our other features. How should we go about doing that specifically with reliability? So here's what I'm going to be talking about today, right? We're going to talk about how do we actually quantify the reliability of our service? How do we use service level objectives to set reliability targets? How do we then, and this is really the sort of the technical bit, is how do we alert on SLOs when we know that we're not meeting user expectations? And obviously, I'm going to be taking questions. So Bart, please, if you do see questions come up, I'm happy to take those as we go if clarification is needed. So let's get into it. So the first thing I want to talk about is this animating principle of site reliability engineering, right? The thing that we have at our core, we really just have one principle, which is error budgets. So what does that mean? Well, in order to talk about error budgets, we have to talk about how to measure reliability. And there is a sort of a simple but somewhat naive way to do this, which is to measure how much of the time things were good over a given measurement window, right? So this is fairly intuitive to understand, fairly easy to measure, that are continuous and binary. So for example, is a server up or down, right? But when we get into more distributed and complex systems, you need more advanced definitions of reliability that can handle situations like partial degradation of service. And things like load balance servers, where you can have some, perhaps some percentage of your infrastructure can have issues without actually impacting user experience, right? But the basic requirement here is the same. We need a definition for reliability, and we need a way to measure it, right? So here's how we're the three terms we're gonna use, right? Bart, you've already brought them up: SLIs, SLOs, and SLAs. And they are different from each other, right? We often have folks that sort of conflate SLO and SLA, but they're actually different from each other. So what does this mean? The SLI, the service level indicator, is a measurement, right? It's a metric compared against a threshold and it tells you for any moment in time whether your service level is acceptable or not. The SLO, the service level objective, is the goal for the aggregate of the SLI over a window of time, right? It's essentially the mathematical bound of the air budget. It says over a given window of time, this is my target. Any amount by which I exceed my reliability target is my remaining air budget. Okay. And finally, the SLA, the service level agreement, is mostly a business concern, much less so than a technical concern, because it specifically defines what you're willing to do, what consequences you will incur if you fail to meet your reliability objectives that you promise to your customers, right? And the consequences are defined when you have an agreement between multiple parties, right? So if you're providing a service to your paying customers, you say like, hey, if we don't meet our reliability targets, we'll refund you this much money. Okay?
And just really quickly to touch on that is the people that are involved in designing these agreements. Who are these stakeholders normally on both on, let's say your team or an SRE team, and then on the customer side, stereotypically, how many people are involved in drafting these agreements?
Yeah, so that's a great question. So if you think about what we commonly think of as an SLA, which is sort of the reliability expectations that you get when you subscribe to a particular service. The people that write that SLA from the provider perspective are basically in finance, product management, places like that, right? They're the ones who look at, we have the service, here are our competitors, here's their SLAs. We know we can roughly meet these reliability targets based on our own technical understanding of the service. Here's the amount of money that we think we might have to refund if we miss our reliability targets over a certain amount of time. So really, that's largely a financial decision. The customer of the service basically chooses the service based on their requirements, and you're sort of assuming that the SLA of the service is high enough for their needs. That's different than an SLO, which is the internal objective, which is the objective that SRE will use to measure service reliability, drive alerting, drive engineering prioritization, some of which I'll talk about in a few minutes. And it will almost always be noticeably tighter than the SLA. Because obviously you don't want to get to a point where you've actually violated your SLA, where you have to refund money and things like that. So you want your internal reliability objectives to be tighter than your external promises, so that you can actually be ahead of problems and get to them before have to give money back. Does that make sense? Does that answer your question?
Yeah, no, it's good. We got a question from someone in the audience. And maybe we'll address this a little bit on later, but I think it's appropriate now too. Does SRE engage with, does customer reliability engineers, do they engage with customers about discussing in or solving and providing suggestions to their technical debt?
Yeah, that's a good question. And so this is more specifically to do with my team rather than sort of the basic topics we're talking about. But I would say that any and all topics that might impact service reliability would be within the scope for my team for customer engagement. Technical debt can obviously mean lots and lots of different things, but so the question is what is the actual impact of that debt? If it's a reliability risk, then yeah, we can absolutely engage on that topic. Very often, in my experience, technical debt is a risk, not a risk, but it impacts toil, meaning that it requires you to do things in a more difficult way than you might otherwise. And that's obviously also something that's in scope for our team, right? We do work with customers on automation and sort of improving their operational processes. So maybe that's a long-winded answer of saying that, yeah, that is something that we engage with customers on.
Great, perfect, thank you.
Of course. Okay, so getting back to measuring reliability, we've defined these three terms. We've defined a service level indicator. We've defined, which is the thing we're going to measure to tell us whether our service is reliable enough. We've defined a service level objective, which tells us what is reliable enough over a given time window. And finally, we've defined the SLA, which is the agreement we make that says if we miss our target, what are going to be our consequences. All right. So the next step is to actually setting our targets, right? What is the amount of reliability that we are trying to reach? Okay. And I'm sure you've heard the terms, 3 nines, 4 nines, 5 nines, whatever the case may be. But really, it's about the amount of downtime or unavailability or unreliability that our service can tolerate. Okay. This approach also means that for systems like the ones we run today, where a complete and total outages is very rare, right? This also gives us a way to measure service degradations, partial degradations, and measure their impact to our SLO or even our SLA. Now, one obvious question folks might have here is like, well, why does this chart stop at 5 nines? Why not 100%, right? Shouldn't we be trying to hit 100%? Well, a key realization from Ben Trainer-Sloss, who founded SRE at Google, was 100% is almost always the wrong reliability target, right? So why is that? Well, let's explain that, right? If we think about a chart that shows us the reliability of our service plotted on the horizontal axis, which linearly, or maybe sometimes sort of super linearly scales with the cost of the service, and we think about our ability to make our users happy on the vertical axis, one might think that this is a linear relationship. The more reliable our service is, the happier our users are going to be. But that's actually not the case. What we see is this nonlinear curve, where below a specific inflection point, our users will be pretty unhappy. Like, that's just not good enough for them. We're going to lose customers. We're going to lose business. However, above that, at that inflection point is that balance, right? Most of users are happy enough. And then above that point, what we know is additional investment in reliability doesn't actually drive additional user happiness, right? Because at that point, our users would prefer that we actually take that engineering investment or other investments and improve service features or improve the velocity of our service rather than focusing on reliability. So that inflection point, that point where we found the right trade-off between how happy our users are and how reliable and expensive our service is to operate, that's the SLO, that's the service level objective, right? Because we know that as we make our service more reliable, it takes more infrastructure, more automation, more engineering time, better incident response, better monitoring. All of those things continue to increase. And the rough rule of thumb that we use is that it basically takes 10x the cost to add one additional 9 to your service. Okay. So what do we do instead of 100%? We need to pick what is going to meet the needs of our users, right? Pick that inflection point on the chart, right? And this really becomes a product management concern. This is the amount of unavailability we're willing to tolerate. That's the error budget. It also allows us to actually use our error budget in an objective way, not just to measure reliability, but to also measure and force it. And now you have a way for everyone who is involved in system reliability, both development and SRE or operations, they have a shared pool of risk that they use to make decisions around velocity and reliability. Everyone's working together, everyone's empowered to manage risk, and it means that SRE or operations knows what to focus on, right? At any given time, based on how much air budget you have burned, you can either focus on improving reliability if you have lots of air budget remaining, or if not, you spend your time improving the reliability of the service, right? And we know that we typically consume or burn error budget as a result of change, okay? And so we want to improve our change management in order to pursue maximum change velocity. So this is all about making software releases and other changes sort of a routine process, right? until we start burning too much air budget, start exhausting the air budget, and then we need to slow it down, right? But this is the key point, is that air budgets are a way to increase the velocity of your service while maintaining reliability targets. All right, so that's the sort of the basics. This is what we've covered so far, why reliability is important and why using SLOs and air budgets is a great way to set reliability targets for your service. So now we're going to talk about, okay, we've done all of that, but what happens when we have a problem? What should we do? How should we get notifications about issues that actually impact our users if we use this SLO and air budget approach to measuring user experience and user happiness, right? So we're going to talk about alerting, right? How do we actually defend our air budget? Well, we know that we have to do monitoring, right? We have to monitor to understand how reliable our service is, right? We need to measure how well we're doing against our targets. And we need to have high quality alerts that fire when our air budget is threatened. And then obviously you need additional observability metrics to tell us when, if there's a problem, like kind of what's going on, okay? And one of the big things that we recommend that folks think about is alerting on symptoms, not causes. And there's a whole, if you look at the first SRE book that we published, chapter 6 talks about this, right? But the idea is you want to alert on those things that actually impact user experience rather than every possible, hiccup or thing in your infrastructure that may or may not result in a user-facing issue, right? You don't want to overload your responders with too many pages to respond to, right? This can result in alert fatigue. This can result in ignoring alerts, and then folks will actually miss something that's really important, right? If alerting on causes is also somewhat dangerous, because if you alert on an infrastructure problem, it doesn't actually tell you what is happening with your service. All it tells you is like, hey, this server somewhere is not happy. You don't actually know what that means. You don't know if it's impacting users. You don't know how many users it's impacting, in what way. This is why the strong recommendation is to alert on things that actually impact your users, which means alerting on your SLOs, right? And some of the details of this are actually covered pretty well in chapter 5 of the site reliability workbook called Alerting on SLOs. So when you consider alerting on your services, there are basically 4 considerations that you need to take into your strategy. The first one is precision, which is what fraction of your alerts are actually triggered by a real or significant event. Okay. The second consideration is what's called recall, which is what fraction of your events actually result in an alert, right? So precision and recall are sort of, in one way, inverses of each other, right? Precision is what fraction of your alerts are like legit, and recall is how much of the time are you actually able to generate an alert when there's a real problem, okay? The second 2 considerations, or the third and fourth, are first is detection time, which is once an event starts, how long does it take for an alert to fire? And then the final one is reset time, which is basically once the event is over, once the problem goes away, how long does it take for the alert to reset? Now, there's no right value for these considerations, right? It all depends on what you want out of alerts, but you probably want to find the right balance for you while minimizing operational load, which is the number of alerts you receive and respond to, while at the same time being sensitive to your users, obviously. And we found that the best way to do that, again, is as described in chapter 5 of the SRE workbook, is by alerting on air budget burn rate. We're going to do some math now. So what is air budget burn rate? Air budget burn rate is a measure of how fast, relative to your SLO, your service consumes air budget. So for example, a service that has exactly 0 air budget left at the end of the SLO evaluation period has a burn rate of 1, right? Which means you burned your entire air budget over the time you expected to burn it. That's 1. A service that consumes all of the air budget halfway through the SLO evaluation period has a burn rate of 2, and so on, okay? We can calculate our burn rate by looking at 3 main inputs: the SLO and its evaluation period, the amount of air budget that we've consumed or burned, and the window over which that burn happens. So that's our alerting window. Okay. So this is the equation we can use to calculate burn rate that we'll need when we configure our air budget burn alerts. Our burn rate is the amount of air budget consumed by the service multiplied by the evaluation period and divided by the alerting window. At this point, it will probably be helpful to walk through an example. So let's take a specific example. Let's say that our service has an availability SLO of 95% over a rolling 28-day window. Okay. And we want to know if we're having a problem that's impacting our end users. So a great place to start is to create an alert that lets us know that we've consumed 2% of our air budget in the last hour. We use this equation to calculate the burn rate threshold for our alert, which is 13.44. So that's the burn rate that tells us we have consumed 2% of our air budget in the last hour. Okay. We might also want to know if we're seeing a slower burn rate. Let's say 5% of air budget over 6 hours. Again, using the same equation, we know that our burn rate threshold is going to be 5.6. Okay. So the next obvious question you might have is, okay, well, like I get all that, but where do those numbers come from? How do should I arrive at the numbers that I put into this equation? How much of my air budget should I actually expect to burn before an alert is triggered? So again, there's sort of there's two simple recommendations, which is we can use what we call a fast air budget burn, which is 2% of air budget in an hour, and 5% in 6 hours, which is the two examples I just walked through. Okay. You can also create a second alert, which we would call a slow air budget burn rate alert, which is basically something like 10% of your air budget over 3 days. All right. So this way you can catch high error rates pretty quickly and lower error rates over time without overwhelming the on-callers with alerts. Okay. So let's have a look at a specific implementation example, how we might actually do this. And obviously I work at Google, so this is what I'm familiar with. This is our SLO monitoring in Google Cloud Operations, right? This is where air budget burn rate becomes important. To configure the alert, we're going to specify a look back window. In this case, it's 60 minutes, 1 hour. And then we specify the burn rate that we expect to hit during that window as our threshold. Okay. Now remember, we just calculated that to be 13.44. Okay. So now when our service has an issue, we'll see the air budget decrease. We'll see the air budget burn rate go up. And we'll get an alert that looks like this, showing us air budget burn during the incident. Note that we're specifically alerting to let us know that our service is burning air budget. Okay. There is nothing here that tells us why it's happening, right? This is the difference between monitoring and observability. That's a separate topic, right? But very much look to avoid the trap of alert on infrastructure issues. That's going to be really noisy. You'll have alert fatigue and you'll suffer from operational overload. Okay. Let's see if this video plays and the sound shares. So if you want to see more videos like this on this topic and others, I have a YouTube series called Engineering for Reliability. Have a look there.
Yeah.
But that's the end. So it's going to summarize what I've covered today. Reliability is a key feature of your service, right? This is what makes the difference between users being able to use every other feature. Because it's a feature, you need to measure it and you need to set targets for it. And those targets should be expressed as service level objectives or SLOs, which result in you having an air budget to allocate for both routine and non-routine issues. To let you know when there are problems that are actually impacting users, you can alert on symptoms rather than causes, and you use air budget burn as the signal that something is actually wrong. So thank you again for having me. I would love to answer any questions that there may be out there.
Perfect. All right. Well, we got another one from the audience. What are the best practices that the SRE and CRE team should follow while writing RCA?
That's a good question. So I would say there's one big thing that whether you call them RCAs, postmortems, which I think a term that is going out of vogue, or retrospectives. I think the one best practice that makes them successful in my experience is this culture of blamelessness, which means the objective of the RCA is to find systemic issues that can be prevented in the future such that this particular class of incident doesn't happen again. It is not about finding the person who is at fault. It is about finding gaps in system architectures, alerting, monitoring, troubleshooting, diagnostics, logging, dashboards, whatever the case may be. So you're looking for sort of a few classes of action items that you can take from the RCA, which are things around detection, prevention, and mitigation, right? So how could we have caught this sooner or faster? How could we have mitigated it more effectively or quicker? And what could be done to prevent this from happening in the future? But the only way you can get to that meaningful information is if people can be honest, if they can really tell you what happened without worrying that it's somehow going to have an impact on their jobs or their careers. And that's where this culture of blamelessness has to be in place, where you have to talk about, we're looking for systemic issues. We're looking for problems that we can impact, that we can fix with engineering effort. We're not looking, or maybe other things, right? I mean, there could be issues with on-call preparedness, training, things like that. But all of that has to be, addressed in an honest and safe way for where people can actually bring these issues up and not feel like they're somehow putting themselves at risk by being honest. So that's the one thing that we absolutely insist on. Certainly, I think we do a pretty good job of it here, and this is something we train our customers as well, is that culture of blamelessness during the RCA is absolutely critical.
And to dig a little bit deeper there, because I think just from this presentation, since we talked before, your style and approach, I see you as being very much a people person in terms of being able to connect. Not everybody necessarily has that. I'm just saying, in order to create that culture in a space where blamelessness will be removed, because customers can get angry. They're not hitting their targets, and the frustration levels can be high. And classic examples when we're talking about SRE will frequently be e-commerce on high traffic peaks, like, Black Friday. So stress levels are very, very high. And it's like, no, we want a scapegoat. I want to take all my anger out on somebody rather than looking at a process. What are some tips that you might recommend in order to make spaces, that where those conversations can exist in a productive way and where real practical results can come out that will help prevent them from being repeated?
Yeah, I think that's a good clarification. So the first part is this is something that I think is something that we do internally pretty well, and we coach our customers on this as well, is during the incident itself, you're not going to be doing root cause analysis. While you are burning air budget, you're focused on triage and mitigation. Triage meaning, okay, what is happening? How many users are impacted? In what way? How bad is the problem? And then mitigation is, what is the fastest thing we can do to restore the service to a good state? So there you're talking about things like, let's say rerouting traffic around a bad network connection, adding additional capacity if your service is overloaded, rolling back a release if you think your last push broke something, those kinds of things, right? You're not trying to get to the root cause and actually fix the problem. You're just trying to mitigate the problem from burning any more error budget, from impacting any more users. Once you've done that, once you've restored the service to a somewhat healthy state using emergency measures, then you can move to the RCA phase. So part of it is never doing the root cause, never doing RCA while the incident is still in flight, right? That should be a sort of after the fact, we've all calmed down, we're not actually stressed right now. Let's really figure out what happened. So that's the first part, is you have to do it in a during a time when the fire has been at least put out, right? The second part of it is, obviously if this is a customer facing service or whatever service you're running, you have someone who is your customer. Yes, they're going to be unhappy, but the internal analysis has to happen first before you kind of do it together with the customer. You have to understand what went wrong. What is it that we actually did to break the service? We know that an overwhelming amount of the time it's because we changed something. So what did we change? Was it a configuration? Was it a software release? Was it code? Was it network configuration, right? Was it infrastructure? What did we change that actually caused this particular issue? And then kind of, again, how do we do a better job of detection, mitigation, and prevention in the future? Once you have your own incident summary or whatever you want to call it written up, then you can actually do what we call a joint retrospective with the customer, which is you kind of share your findings. And then you try to work with the customer, and this is what my team does a lot of the time, is help your customer be better resilient against this type of failure in the past. So if your service is an API that your customers depend on, and your API had a service degradation over a particular period of time, well, how can your customer be better prepared for that in the future? Do they need to do more retries? Do they need to have a backup plan? Do they need to do caching on their end? What architectural things can they do to actually make their service more resilient, knowing what your dependency is? Do they actually understand what your reliability promises are? And is their service appropriately engineered to making sure that they can deliver on their targets, whether or not you're delivering on yours, right? So I think, to answer your question, there's really two parts here. First part is, you don't want to do RCA under fire. You want to make sure the fire is over. And the second part is, you do it internally first, kind of figure out exactly what happened and what are the things you're going to do to prevent it from happening in the future, and then involve the external stakeholders to kind of share your findings and make your promises to make things better for them. And we found that to be a pretty effective approach.
No, it sounds very effective, but I think it also means really taking the relationship that you have with your team, and B, by extension with your customer, taking that very seriously, seeing it as something that's long-term, that it's not just who's exploiting who, or it's not about that. When you really create a win-win, it takes patience, and I think particularly, I think you really nailed it with because sometimes there's this urgency of we need to address this now. That's probably the worst time, because emotions, our stress levels are high. Things can get, blanketed by emotions rather than, separating things with some distance and looking what went on there. And as you said, take the people out of it. Where was there a breakdown in the process that perhaps, for example, I wanted to ask you about that actually, is it in terms of testing alerts, are there any common mistakes that are made doing that then can lead to a failure when an alert actually needs to be going off?
Yeah, so the one biggest mistake, honestly, is lack of testing, is not testing alerts. That's the biggest thing that, I see it all the time, right? Is people set up these alerts and they just say, okay, great, we're good. We have alerts set up. And you can test alerts in a few different ways. The two obvious ones are, one, sort of depending on how your alerts are configured, is you can, feed them through a test suite. We could actually send them synthetic data and have them evaluate that data and trigger or not trigger. The second way, which is I think feels a little scary to people is you actually break stuff and see if your alert fires. So we call that disaster recovery testing, or DIRT, which you may have heard of. But this, it can be thought of as resilience engineering or chaos engineering.
Yeah.
But basically, you introduce a failure and see if your alert really catches it. Now, obviously, there's different ways to do that. You can do that in a sort of non-production environment where it's a very safe exercise. Once you get to the point where you're pretty good at this, you can actually start doing this in production, because you can introduce failures in a very controlled way. And kind of going back to the fundamentals, your SLO, how much air budget you have left over a given period, and you say, hey, we really haven't had any problems over the last couple of weeks. We haven't tested our stuff in a while. Let's raise our error rate by 1% and see if our alerts will actually catch it. Right. So that's another benefit of having air budget, is that it allows you, exactly when you have room for this kind of experimentation. So to address the original question, kind of right, to test alerts, like one, you should do it. The biggest mistake people make is not doing it at all. And you can do it either in a synthetic way, if you have a test suite available for them, unit testing basically, or you can actually break stuff and see if they fire.
Yeah. Okay. Very, very good to keep in mind. And like you said, I think, testing is probably not something that's ever overdone, rather than what you said is not done enough. Another question that we got from the audience, in terms of SLI, is there a limit, or can it be as many can be added after SLO has been set?
Yeah, great question. So remember, your SLO, your service level objective, is the combination of an SLI, your indicator, and an evaluation window, and a target, right? So if and let's take a very basic example. If my SLI is service availability, which is basically my error rate, right? My SLO is going to be, okay, what is my acceptable error rate over what time window, okay? So adding more SLIs it can help you to have a more complete picture of the reliability of your service. But I do think this is actually a place where folks will typically err, is they will try to start with too many. They will try to use their SLIs to capture every possible failure mode. The idea is that you want to have just really a small number, 2 or 3 basic indicators that show you the reliability of your service. So for a user-facing web service, availability and latency are going to get you most of the way there. If you're very advanced, you can start introducing things like correctness, right? What percentage of the time are we actually returning the response that meets user expectations? Not just in terms of, did we send a 200 back and how long did it take, but like, what did the data actually look like? But the number of SLIs can really be pretty small. It may help you to have SLIs that are focused on specific aspects of user experience. So the way that we coach people through this is, you say, identify your service, or define what is the surface area of your actual service. What are the critical user journeys, CUJs, that people engage with to use your service? What are the things that they actually do? And then how can you build SLIs to capture the success of those, either in terms of availability or latency? And for each, your service may have lots of user journeys, but for each user journey, you're really going to try to create fewer than 5, right? Maybe 3 SLIs at most is what we typically recommend. How you set SLOs against those is, again, you want to start with a smaller number rather than with a larger number, right? You want to start small, start simple, and iterate from there.
Mm-hmm. Going back to what you mentioned in the beginning, closer to the beginning about the stakeholders that are involved in establishing SLAs, is in the same way that someone with an engineering background is going to have to be learning finance and product management. It's the finance and product management folks on the other side, they're going to have to be learning a bit about engineering. How do you sort of reach a level playing field? Because also we find very frequently, and this happens with everything, but when the higher the tech level goes, in some ways, sometimes folks will be more likely to say, I don't know anything, but other times people might feel like they're being pressured to say that they know more than they really do. How can you create an environment where you can really get those things out in the open so that you're starting, to get off on the right foot, basically? Is there any particular approach that you use?
Yeah, so I think one thing that I'm going to kind of keep hammering is to avoid this conflation between SLOs, which are the reliability targets that we'll use when we run our service, versus the SLAs, which is the reliability targets we'll promise to our customer
Yeah,
and then
customer
incur,
facing. Yeah.
yeah, incur sort of the financial consequences or whatever they may be for missing it. But the way you can actually get to a point where sort of everyone on the same page is you need to have some sponsorship typically from executives to say like the thesis that reliability is something that we care about and we're actually going to measure it, invest in it, fix it when it's not there. Yeah, that has to be a culture in the organization. We've seen it be adopted very well again by starting small, like literally with a single service within an organization, demonstrate success over time, demonstrate your ability to deliver, to consistently deliver a reliable service by using these practices, and then invariably spreads through the organization. But even just to do it in that one service, you need some level of management and executive support. Say like, yes, this team will run their service in accordance with the SLO that they've arrived at. But when that SLO is threatened, they will be empowered to do the things they need to do to defend it. So that means like slowing down release cadence, pushing back on infrastructure changes because their service doesn't have air budget available that week or whatever the case may be. You need to have the team that actually owns the SLO be empowered to defend it.
Very, very good. Yes. One thing I know that you said in the beginning, this is, where it's not even necessarily SRE, it's not necessarily Kubernetes, we're talking about one specific element, is that looking at a growing, sort of area and particularly relevant to our community, as we do have many SREs, but also increasing amount of people that are referring to DBREs, database reliability engineering. Would you see any overlap with some of the things that you mentioned today? Perhaps we're looking at different indicators, we're looking at different metrics, but what kind of things might be in common in both areas?
Yeah, absolutely. The indicators and metrics might be different. How you define a service or how you define an SLO for a, let's say a database versus a user-facing service might be a little bit different. But I think the thing that's really going to be in common is the engineering part of it, which is in order to do reliability engineering for any kind of a service, you actually have to have time to do the engineering work, right? So going back to the question about RCAs, one of the things I said is out of that RCA, you're not just going to say, well, here's what happened. You have to identify what are the things you're going to do to prevent it from happening in the future. What are things you're going to do to catch this problem faster? What are things you're going to do to mitigate this kind of problem faster in the future? You have to have time to actually implement those things, regardless of what your service is. And that's the engineering part of SRE or DBRE. And the team that does this kind of work, they have to be able to spend, we say half, the right target maybe depending on the organization, but some non-zero, non-negligible portion of their time has to be protected in order to actually do this kind of engineering work, in order to actually either improve the reliability of the service over time or reduce the operational load it takes to run the service over time, such that they can basically scale out, right? The objective of the team is to engineer themselves out of a job. Now, realistically, that never happens, but that's what you're trying to get to. So the one thing that I see in common between SRE, DBRE is the fact that you need to be able to spend a non-negligible amount of your time actually doing the engineering work that makes your service either more reliable or easier to operate.
Attract your power thing. I think that's interesting because also what you're talking about, when it comes to workload and also when it comes to happiness, on the customer side and how this is measured, in order for that happiness to be achieved, if there isn't happiness on the other side of the technical team that's working on this, it's like you said, budgeting that time in there to make sure that these practices can be done correctly. I think this happens, whether it's agile, whether it's DevOps, people read a book or they see a PDF on the internet, they watch a video and say, all of a sudden, now we're doing agile, or now we're doing SRE, or now we're doing DevOps. Yeah. But if they're really not willing, to put their money where their mouth is and give that time to make it happen, it's only adding more work and then creating expectations and creating more disappointment that will end up in lower quality work, higher burnout. Is this something, would you agree with that?
Yeah, absolutely. I think one of the sort of the easy traps to fall into is just take an existing operation team, call them SRE, and move on. Right? You're giving them a new title, but you're not really changing the way they operate. You're not changing their expectations. You're not changing the work that they're doing. So that kind of thing is something we've definitely seen. It. Yeah, you're absolutely right that it inevitably leads to the exact outcomes you're getting today, just under a different title.
Yeah. You've been producing some videos. Do you have any other ideas for content in the future based on the stuff that you've seen, the mistakes, the problems, things like that?
I probably have a more general answer to that question than the one you're looking for, which is a lot of the stuff that I've been working on over the last couple of years has really had to do with observability, which is kind of understanding your service better, right? Getting metrics, traces, logs, other telemetry from it. I'm very interested in more of the architectural parts of reliability, which is, how do you actually, given a particular reliability target, how do you actually architect and build a service to deliver on that target? So I hope to expand some of my content into that area.
Yuri, sorry.
No worries at all.
Sorry, we're talking about, reliability and my internet crashes. So just to finish up though, wanted to ask you in terms of a content perspective, you made some videos. Do you have anything else in the pipeline that you want to be working on?
Yeah, I answered this, I think, but I think you dropped. So just kind of summarize. I've spent a lot of my time making content around observability, monitoring, logging, alerting, SLOs, things like that. I would like to kind of shift my focus a little bit and talking about sort of architecting for reliability. So once you have a service defined and the reliability target set for it, how do you actually build your service in a way that'll meet those targets, and what are some of the other concerns that have to go into it around operational practices, incident response, and things like that.
Very, very good. Well, one thing that we have before we finish, and we're definitely going to be linking the videos so that folks can check that out, because very practical, very, very hands-on. And it's funny because like a lot of times it seems that these things end up becoming more complicated than they really need to be. And actually there's something that was mentioned in a previous live stream this week, was what the speaker was referring to as accidental complexity, that without wanting to, that a lot of these things end up sort of spitting out and sounding, making it really complex, and then making the learning curve really, really steep. For most of the stuff that I've seen from coming out from the SRE team to Google, it's very hands-on. Okay, let's make this simple. I say that as a person who's by no means an expert and doesn't intend to be, So my litmus test is always like, if I can understand it, other people probably can too. So it's nice to see that it's a breath of fresh air. Before we go though, we got one thing just wanted to share. Let me know when you can see my screen.
I'm there.
Okay, good. So while you were talking, we had our wonderful graphic recorder, Angel, who created a visual representation, the stuff that was that you were mentioning. Not sure if you're a Star Wars fan or not, but I thought it was nice that he put some TIE fighters attacking a website. And the sort of the core principles that were mentioned there. So anyway, very, very nice session with you, Yuri. Hope we can have you back and keep doing the great work that you're doing and making this stuff a lot easier to understand. Much appreciated. Is there anything, for folks that want to follow you, check you out? We got Twitter, LinkedIn, anywhere else?
No, I think everything I do, I end up sharing there. So that those would be great places to find my work.
Perfect. All right. Well, thank you very much for your time today and hope to see you soon.
Thank you so much. It's a real pleasure to be here.
All right. Take care. Bye-bye.